Something that I am going to ask of you is to go back to 8th grade. We're pausing for geometric sequences and we're just looking at arithmetic sequences for a moment because unfortunately for you, I expect you to remember stuff that you were taught. Okay? What I need you to do is look over this problem 3. This problem 3 is a recursive formula for arithmetic sequences. Okay? Here is the recursive formula for this arithmetic sequence. Here is how you can apply it. This is the recursive formula. Please pause the video and read that over. Something else you were taught is an explicit formula for the arithmetic sequence. Given this arithmetic sequence that I'm pointing at, they have walked you through how to find the explicit formula. The explicit formula is right here for this sequence. I do expect you to pause the video and make sure you remember it. Down here is how to use it, but there is how to get it. I do, again, expect you to pause the video and look that back over if you can't remember it on your own. Now back to today, using sequences. And what we're going to look at is 2 types of sequences. We're going to look at geometric versus arithmetic. We're looking at 9th grade versus 8th grade. 2 managers at a clothing store created sequences to show the original price and the markdown prices of an item. Write a recursive formula and an explicit formula for each sequence. What will the price of the item be after the 6th markdown? Let's focus, please, on the first sequence. The first sequence goes 60, 51, 43, 35, 36, 85. What we need to do is check if that is geometric or arithmetic. To check that, I plug it into my calculator. I do the 51 divided by 60. Then I do 43.35 divided by 51. Do you notice how I'm getting the same thing? Is that right? That's right, they just had to round probably to the nearest penny. Each time I am getting 0.85 when I divide. So since every time when you divide you get 0.85, that is your common ratio, which makes this geometric. Your common ratio is 0.85. The first term is 60. Your recursive formula, you take anything you want to get, is found by taking the one before it and multiplying by 0.85. This is the recursive formula. Both of those make the recursive formula up. The explicit formula, if you need to go back to your old notes, or like a couple pages back, for geometric, anything you want to find, you take the first one, you multiply by the common ratio, and you take that to the n minus power. Now, they ask us to find it after the 6th markdown. Many, many, many people are going to want to substitute in a 6, right? Because you're like, well, it's the 6th markdown. I hope you're listening very well. Even though it's the 6th markdown, that's not the 6th price. That is the 7th price, because you have to consider that it was originally something else. So you have the original, the first markdown, the second markdown, the third, the fourth, the fifth, the 6th markdown. That's why they're substituting in 7. So here's my original price. Here's my common ratio. 7 is the spot that I am looking for. So they are saying, look at this, your answer in the 7th spot. Did you pay attention? Your answer in the 7th spot is $22. Sorry, you can't see that. There you go. 22.63. So originally, let me write it down, 22.63. So originally this sweater or whatever it is, originally this item was $60. It's being marked down so that after the 6th markdown, the price is $22.63. Now let's go to the other store. The other store, we notice, it does not divide each time. Let me show that to you. 52 divided by 60 is not the same as 44 divided by 52, which is also not the same as 36 divided by 44. It's changing every time. What I hope you notice is that this time, what's happening is it is subtracting 8 each time. So this time we have a common difference of a -8. This is not a division problem. This is a common difference problem. This one is arithmetic. So the first spot, again, is 16. That defines part of the recursive formula. The rest of the recursive formula says you take the one that you want, and to get the one you want, you need to take the one before it, and then you need to minus an 8. And that is how you write the recursive formula for arithmetic. Now the explicit formula. The explicit formula says to get the one you're looking for, you take your common difference of -8, you multiply that by n minus 1, so whatever you're looking for minus 1, and then you add your original value of 60. Kind of like a y equals mx plus b equation. We want to find the 7th price. So we say, well, what is -8 times the quantity of 7 minus 1 plus 60? And this will be what happens after 6 markdowns. Again, it is 6 markdowns, but it is the 7th price, so we plug in 7. So this sweater, or whatever it is only going to be $12 because it's being marked down a certain amount each time, whereas over here it was a % of markdown each time. Whew, that was a mouthful. That probably required a lot of you going back to your 8th grade thinking skills there. Last one, write a recursive and an explicit for each sequence below. Find the 8th term. All right, we got it. First, we need to figure out geometric or arithmetic. Try dividing first. When you divide each one, 84 divided by 14, 504 divided by 84, 3024 divided by 504, each time we get 6. Since each time we get 6 when we divide, remember we tested for division, that makes this geometric. We can do this, guys. We just did this on the last example, problem 2. Gotta memorize these, okay? Recursive formula starts with what the first term is. In this case, A1 is 14. And then it says to get to anything after that, you take the one before it, and you multiply by 6. That's the recursive formula. Now for the explicit, probably a little more useful. You say to get to anything you want to find, you need to take the first number you got, your initial value, multiply by your common ratio, and take that to the power of n minus 1. Now remember, they wanted us to find the 8th sequence, okay? Did you see that up here? So to find the 8th sequence, we need to plug in 8. Let's use our explicit formula. Okay, you know that's just going to be a 7 in your parentheses, right? So we get 14 times 6 to the, well, you can just do 8 minus 1 is 7, you know that. Look at that huge number, but it is correct. Let's see here, can we read it? 3,919,104. And remember, I really shouldn't have put an N there. I should have said my 8th spot. So A of the 8th spot is 3,919,104. Now, would that be true? Well, why don't you figure it out? If this is spot 1, 2, 3, 4, you would have to go 5, 6, 7, 8. You would have to multiply by 6 each time. Well, if you continued that through until the 8th spot, that's the number you would get. All right, we are done almost with recursive and explicit formula, okay? Take a look at this one, divide it out. When you divide this out each time, I think you're going to get 0.5. There you go. Let's try the other one. Yep. Each time we're getting 0.5 when we divide, right? That means it's a common ratio, which means it's a geometric sequence. Let's do our icky recursive formula and then the nicer explicit formula. The recursive formula starts with what the first number is. So in our case, 648. And then it tells you to get to the next, to get to anything you need, you take the one before it and you multiply by your common ratio, in our case is 0.5. Now for the better one, the explicit formula. To get anything you want, you need to take your first number, 648, times your common difference, or excuse me, your common ratio, in our case 0.5, to the n minus 1 power. So this is 1, 2, 3, 4 spots big. We could continue this out if we wanted to, all the way to the 8th spot. Or we can just plug 8 into our explicit formula. And you know 8 minus 1 is 7, right? So I'm just going to put that in the calculator. .0625 is the answer. So if you did that sequence 8 times, in other words, if you kept continuing with your common ratio 8 times, you would come to 5.0625. We're almost done. You can also represent a sequence by using function notation. You again learned this with Mr. Lankus, I believe in Chapter 4. This allows you to plot the sequence using the points n, that's what spot it's in, that's the spot number, and a sub n, which is the actual number that you, whatever number you actually see, where n is the term number and a and n is the actual term. Let's try this. Let's try graphing. Okay. A geometric sequence has an initial value of 6, that's A1, and a common ratio of 2, that's R. Write the function to represent it and then graph it. So we write a to the n equals my first number 6 times my common ratio 2 to the n minus 1. So we can replace this with y equals 6 times 2 to the x minus 1, so we can actually make an xy chart. This should take you back more or less to yesterday when we were graphing these things, or maybe even the day before. okay? This is going to be growing. You can plug in negatives if you would like. Let's try -1, 0, 1, 2, 3. Actually, I apologize. We're not going to do negatives in 0 because since n, or x, is technically n, that's what spot you're at on your sequence. Does that make sense? It's what spot you're at. So if you plug in a 1, you're saying my first number is. If you plug in a 2, you're saying my second number is. Okay, let's just do 1 through 5. Again, these represent spot numbers. So 6 times 2 to the 1 minus 1 is really just 6 times 2 to the 0, which is just 6 times 1, which is just 6. 6 times 2 to the 2 minus 1, that's really just 6 times 2 to the first, which is really just 6 times 2, which is just a 12. Okay? And then 6 times 2 to the 3 minus 1, are you ready? That's 6 times 2 squared, which is 6 times 4, which is 24. Hopefully you're noticing a pattern here, right everybody? 6 to 4 minus 1 is really 6 times 2 to the third. That's 6 times 8. That's 48. Do you notice here the geometric sequence happening? And then 6 times 2 to the 5 minus 1 is 6 times 2 to the fourth, which is 6 times 16, or 96. Again, notice the geometric sequence going on. Let's plot these. Let's skip by 1s on our x's, but let's skip by 10s on the y. Okay, 10s on y-axis. Over 1, up 6. So this is 10, 20, 30, 40, 50, and so on, okay? Over 1, up 6. Over 2, up 12. So not a huge increase there, right? Over 3, up 24. Okay, that one went up more. Over 4, up 48. That one went up even more. Hence the exponential functions, hence why this is in chapter 7. Over 5, up 96. Oh, that is tall. So you can really start to see this thing grow. It takes on a J look, and it will continue up. Now, if we did plug in negatives, it would approach your x-axis but never touch. So you can finish it off that way. That's a really bad arrow. All right, last one, okay? Promise. Last one. Let's try to do this one in 2 minutes, okay? Geometric sequence. So a sub n has an initial value of 2 and a common ratio of 3. That's how easy it should be to make your formula. We can make that y equals 2 times 3 to the x minus 1 for our xy chart. Remember, please, that x stands for what spot you're at. So we'll plug in 1, 2, 3, 4, and 5. So we do 2 times 3 to the 1 minus 1, which is just 2. And then we do 2 times 3 to the 2 minus 1, which is just 6. 2 times 3 to the 3 minus 1, which is 18. I'm doing them real fast in my head. You should be able to do them. Maybe not quite as fast, but you should be able to. 2 times 3 to the 4 minus 1, 54. And 2 times 3 to the 5 minus 1, 162. I don't really care what you guys skip by. I'm going to skip by 20s. Okay, my y's are going to skip by 20s. And let's plot them. Over 1, up 2. That's really low. Over 2, up 6. Again, that's pretty low considering this number here is 20. Over 3, up to 18. Over 5, up 1, over 4, up 54. Okay, so that's going to be between 40 and 60. And over 5 up 162. 80, 100, 120, 140, 160, and literally right above that. Again, you can see your line starting to form. It would approach the x-axis but never touch. So I hope you guys kind of got your heads on straight here about recursive versus explicit formulas. That was really the main gist of the lesson. I hope you understand that n is just whatever spot you're needing to find. Like if you want to find the first, the second, the third, the fourth spot, a sub n is the actual number that you need to find. You might want to go back and look some more stuff over. Have a good night.